Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And we're going to be talking about a term that I don't think I've mentioned before in all the months that I've been doing this. And that's something called the boundary layer. And it's really a fairly simple concept. And you probably, without even realizing it, have noticed it when you fly in an airplane, especially in the summertime. You know how it gets really, really hazy in the summertime, and so the plane takes off, and then you reach a certain altitude where all of a sudden the haze is gone. In fact, sometimes you can see a very sharp demarcation between the haze and the non-haze, and then the sky becomes crystal clear. And so the boundary layer is where that haze is concentrated, and then above the boundary layer there's an inversion which traps the haze in that location and does not allow it to disperse higher up into the atmosphere. And so if you've ever been on an airplane and seen that, you know, where all of a sudden it's murky and then it's just beautiful above that, then you have witnessed the top of the boundary layer. Well, let's actually get into a more formal definition of things here. And here we go. So the official definition in meteorology is the bottom layer of the troposphere, which is the part of the atmosphere where 99% of the weather occurs, that is in contact with the surface of the Earth. So what happens is when the sun comes up in the morning, it starts to heat the ground heats the air above it, the air heats the air above that, and basically you start to mix the atmosphere over a deeper and deeper layer, but it all initiated, or was all initiated by the fact that the sun heated the ground and then everything transpired from there. Now, during the winter time, the sun is fairly weak, and so you may only have a boundary layer that's 2,000 or 3,000 feet thick. In the summertime, when the sun is really strong, sometimes you can have a well-mixed atmosphere all the way up to 6,000, 7,000 feet, you know, very, very easily. So I wanted to show you just a few examples of a forecast sounding for this week. And here's one, and this is from the program BuffKit, which I think I've mentioned several times before. If you're a weather enthusiast, you want to do a search for BuffKit and download this program because it does so many cool things. But anyway, I've got the altitudes labeled here. This is 5,000 feet, 10,000 feet, goes all the way up to 30,000 feet. And where you see the temperature, the red is temperature, the green is the dew point, where you see the red temperature line, that's almost straight, okay? That's going right along what we call a dry adiabat. And basically, when the atmosphere is well mixed, then the temperature will descend at a rate of about 5.5 degrees per 1,000 feet, which is the dry adiabatic lapse rate, okay? So in this particular situation, if you sort of guesstimate here, this is 5,000 feet, so maybe we're mixed up to about 4,000 feet, okay? Now, let's move on ahead to a sounding later in the week, and look at this. Now all of a sudden you've only got that straight line extending up to about 2,000 feet, and there's an inversion above that where the temperature actually increases with height. And so on this particular day, the atmosphere is only well mixed over a couple of thousand feet, and the boundary layer is fairly shallow. Then, as we take a look at our third example here, the boundary layer extends almost up to 5,000 feet. And so basically, when you see a forecast sounding, you want to look for the part of the sounding that is exactly along the dry adiabat, or nearly exactly along it, and the temperature is descending at a rate of 5.5 degrees per 1,000 feet. And then once you see any turn toward the right, okay, which would signify an inversion, then that's where the boundary layer stops, okay? And that's where, if you're in an airplane and you see that demarcation between the haze and the clear skies, that top of that haze layer is exactly where that inversion is, and that's why the haze is trapped and cannot mix vertically higher up into the atmosphere. So there's a lot of different ways that you can look at the boundary layer. You can look at it from how deep the atmosphere is well mixed, okay? It's almost like taking a spoon and stirring it, and everything is very, very well mixed and dispersed very, very nicely. And then once you get into inversions and so forth, it gets a little bit more complicated. The other thing is that friction affects the strength of the wind near the ground, okay? And so even though there's, not friction with the ground higher up, the fact that the wind was reduced by friction at the ground affects the amount of momentum that is then in existence across the rest of the boundary layer. So basically, any part of the atmosphere that is well mixed and in contact with the ground is the boundary layer. And then once you get above that, then there is no effect from the surface of the Earth at all. And so that's the rest of the atmosphere, or the non-boundary layer, if you will. Does that make any sense? I hope so. So anyways, that is bonus weather video number 1 for this week. Hope you found that at least mildly intriguing. The next one coming up on Wednesday, and so we'll see you then. And of course, we'll have another daily weather update for you coming up tomorrow. You all take care, folks, and we'll talk to you soon. See you later.